So, have you ever just stopped and wondered what the universe is really made of? I mean, we know most of it is this invisible stuff called dark matter, and for decades we've been looking for it. But what if we've been looking for the completely wrong thing? Today we're going to dive into a really clever new idea. What if we could finally find dark matter not by seeing some big flash of light, but by seeing its shadow?
You know, when we look up at the night sky, we see this incredible cosmic show. You've got stars, nebulae, entire galaxies stretching across billions of light years. It feels absolutely huge, almost infinite, right? But all of that, literally everything that shines, everything we have ever seen with our telescopes, is just 15% of all the matter in the universe. Just let that sink in for a second. Everything we know and see, you, me, this planet, every single star in the sky, is just a tiny, tiny fraction of what's actually out there. And that question right there leads us to probably the single biggest mystery in all of modern physics. If 85% of all the matter in the cosmos is completely invisible to us, what in the world is it? Well, this invisible stuff, that's what we call dark matter.
Okay, so let's start with what we actually know about this cosmic ghost. It's a real detective story, and believe me, scientists have gathered some pretty fascinating clues over the years.
What's kind of wild is how much we've figured out about something we literally can't see. We know it has mass because its gravity is the glue holding entire galaxies together. Without it, they just fly apart. We know it doesn't interact with light, which, is why we call it dark. And we know it's cold, which just means it moves around pretty slowly. That's actually super important because that's what allowed all the cosmic structures we see today to form in the first place.
And just like in any good mystery, scientists have also ruled out all the usual suspects. For a while, we thought it might be these tiny particles called neutrinos, but they're just too light and way too zippy. So this means dark matter has to be something completely new, a particle that doesn't fit into our current rulebook for physics, the Standard Model. So since we can't find it in our existing particle zoo, scientists have had to get creative and come up with theories about what it could be. And that brings us to the #1 suspect in this whole cosmic whodunit.
Everybody, meet the WIMP. It's a great name, right? It stands for Weakly Interacting Massive Particle, and honestly, the name says it all. The theory is that dark matter is made of these heavy, super elusive particles that basically ignore everything else, which is exactly why they're so ridiculously hard to find.
Now it's really important here to separate what we know from what we think. We know for a fact dark matter exists and has gravity. The WIMP, on the other hand, is our best guess for what it's made of, and this theory is so popular because it makes a prediction. It says that every now and then, two WIMPs should collide and create a faint flash of high-energy light that we could, in theory, actually detect.
And this is the idea that's been driving the search for decades. The logic is simple enough. You point our most powerful telescopes at places where there should be a ton of dark matter, like the center of our galaxy, and you wait. You listen for the flash of gamma rays, which is just super high-energy light, from a WIMP collision. It's kind of like trying to hear a tiny single firecracker go off in the middle of a huge silent forest.
But here's the problem. After years and years of listening, that forest has been stubbornly, frustratingly quiet. We've seen a few little hints here and there, but nothing that you could call solid proof. The flashes just aren't showing up, and that is forcing scientists to get a whole lot more creative.
This, well, lack of evidence, has really opened the door to a radical new idea. I mean, if the old search method isn't panning out, maybe we've been looking for the wrong kind of clue this whole time.
And this right here is the brilliant, game-changing insight at the heart of a new study. Forget trying to see dark matter give off light. What if we could see the effect it has on light that's just passing through it? So instead of looking for a flash, we'd be looking for a subtle shadow or maybe even a tint.
So here's the basic idea. Light from a really distant source, say another galaxy, travels for billions of years to get to us. And on that epic journey, it has to pass through this immense, invisible ocean of dark matter that fills all of space. The new theory says that this journey isn't a free ride. Dark matter actually takes a tiny, tiny toll on that light as it passes through.
And this interaction could change the light in one of two ways, depending on what dark matter is actually made of. And this is the wild part. It could tint our entire view of the cosmos either slightly more red or slightly more blue. Okay, so this new theory gives us two very clear testable predictions.
On one hand, if dark matter only interacts through gravity, then as light passes through, it gets a tiny little gravitational kick forward, giving it a bit more energy. That would shift the light towards the blue end of the spectrum. But if dark matter is a WIMP, its interactions could actually knock light particles backward, making them lose a little energy. That would shift the light toward the red. All of a sudden, we have a way to tell them apart. Is the universe tinted blue, or is it tinted red? And the answer would be a huge deal. A blue tint would mean dark matter is even weirder than we imagined, and that the WIMP theory, well, it would mean that cornerstone of physics for decades is just wrong.
Now, let's be totally clear here. This effect would be unbelievably small. We're talking about a change you would never ever notice with your own eyes. But, and this is the crucial part, it just might be large enough for our most sensitive instruments to actually pick up, turning this cool theory into a real, observable test.
So, where does all this leave us? We've got this powerful new theory, but can we actually test it? The answer is, well, it's a tentative yes.
And this is where it gets really exciting. When scientists went back and checked the existing data, they found that our current measurements are just about sensitive enough that they're compatible with both the red and the blue tint theories. We're right on the edge of an answer, but our observations aren't quite sharp enough to tell the difference between them. At least, not yet.
So what comes next is pretty obvious. We need better data. Sharper observations aimed right at that dense cloud of dark matter in the center of our galaxy could finally shrink those margins of error. And that would let us see, once and for all, if the cosmos is tinted red, blue, or not at all.
The authors of the paper end with this really beautiful thought. After decades of searching for some bright, flashy signal, maybe the answer has been hiding in plain sight all along, subtly coloring our entire perception of the universe.
And that's the thought I really want to leave you with. This whole new approach is such a great reminder that sometimes the biggest discoveries aren't loud explosions, but faint whispers we just have to learn how to hear. If it turns out our whole universe is tinted, it really makes you wonder.
If you're ready to explore the hidden truths behind mysterious sciences, subscribe now and become part of the enlightened society.